Let's look at this example, another example of a fractions question. This is taken from the June 1990 CXC Mathematics past paper. Now you have 4 1/3 minus 1 5/6 all divided by 1 3/7 multiplied by 1 2/3. Of course, the first thing you're going to do is to change these mixed fractions into improper fraction. Now you have, for example, 4 1/3. That's 3 4s 12 and 1 13. And remember, if there's anything here that you don't understand, you should refer back to the videos that I did explaining the principles behind these things, or of course make a comment in the comment section so that I can address your question. Now 4 1/3 minus 6 1/6, 6 and 5 11, 11 divided by 6 all over. And I don't want to mix up the question with the working that I'm doing, so let me just put the question in a box by itself. Alright, all over 1 3/7, 7 1s is 7, 7 plus 3 is 10, so that's 10 over 7 multiplied by 3 1s 3, 3 plus 2 is 5, 5 over 3, right? Now, just as a quick review, let us look at the explanation why 4 1/3 is the same as 13 over 3. So you have 4 items, 1 2 3 4 holes, plus 1/3 of that item. It's about like this. Now this 13 over 3 is saying 13/3. This is saying 4 holes plus 1/3. How many thirds are there here? That's 3/3, 3 equal parts. If I divide up each hole into 3 equal parts, I have 3/3. Here is another 3/3. Alright, I'm going to third up this one. That's 3/3, and that's 3/3. How many thirds I have? 1 2 3 4, so 1 2 3 4 5 6 thirds, 7 8 9 thirds so far, 10 11 12 thirds, plus one more third give me 13 thirds. Alright, you see that? You can do it that way as well. Now here, when you multiply 3 by 4 you get 12, so that was a 12/3. 4 holes, how many thirds do you have? It's 3/3 for each multiplied by the 4, giving you 12, and then you add one more up the top giving you 13, so it's 13/3. The same thing applies for the other mixed number converted to mixed fractions converted to improper fractions. So 6 1/6 and 5 11, 11 over 6, 7 1 7 and 3 10 over 7, 3 1s 3, 4 5, 5 over 3. Alright, good. Now let's look at the top part here. 13/3 minus 11/6. Here I could multiply the 3 by 2. If I multiply the 3 by 2 and multiply the 13 by 2, then I would have a certain number of 6's to minus 11/6 from it. Now here 13 by 2's is 26 up top over 3 2's, 6 down the bottom, minus 11/6. You see that? So what I'm saying here now is I don't even need to draw this line. If you have 26 sixths minus 11 sixths, how many sixths do you have? It's like saying you have 26 oranges and you take away 11 oranges. How many oranges do you have? Well, that would be what? 15 oranges. So 26th of 1/6 minus 11 of 1/6 will give you 15 1/6. Because this 26 over 6 is the same as 26 multiplied by 1/6. And this 11/6 is the same as 11 times 1/6. 26 multiplied by 1/6 would give you 26 over 6, just like this. And I could put this 26 over 1 if I want, fraction multiplied by fraction. But let's not do that here. No. 26 6 minus 11 sixths will give you what? You could, if you want, factorize and put 1/6 as a common factor outside a bracket, and 26 minus 11. So how many 1/6 do you have? It's 15 sixths, right? It's just a matter of explaining the principle. I didn't really have to go through all of this here, but it's important that you understand the principle, right? Not just be able to pass the exam. You should understand the principle, particularly if you're doing any STEM subjects. You need to have a greater depth of understanding than others would need. Alright, so that's 15 6. Just does the top part here. We haven't touched the 10 over 7 times 5 over 13 yet. Now let's just erase what I have up here to make some space. Here now, all of this comes down to 15 over 6 all over 10 over 7 times 5 over 3. So this is 15 sixths all over. Now you remember your multiplication of fractions is 10 top times top, 10 5 50 all over bottom by bottom, 7 3s 21. You see that? So you have 15 over 6 all divided by 50 over 21. Let's see how that works. It's 15 over 6 multiplied by what? Remember, you have 15 over 6 divided by another fraction is the same as 15 over 6 multiplied by the reciprocal of that other fraction. So it's 21 over 50. Alright? So you notice we could cancel down and get smaller numbers instead of trying to work with these bigger numbers, which we'll have to cancel down later anyway. Alright, so we could cancel down using 3. Alright? Because 3 into 6 goes 2 times. 3 into 21 goes 7. You see that? Let's do that again. Three into 6, 2. 3 into 21, 7. Alright? 5 into 15 is 3. 5 into 50 is 10. So what you have here is 3 over 2 multiplied by 7 over 10. You see that? So what do you end up with? This, let's just erase this part for now. You don't want it encroaching in the space of our answer. 3 times 7 up top is 21 over 2 tenths 20. So it's 21 over 20. Now what is this as a mixed fraction? How many 20s are there in 21? There is one big 20 plus one more left over, and 1 over 20. Alright? So it's 1 and 1/20th. So let's just do a quick review. 3 4s 12 over 1, 13 over 3 minus 6 1 6 and 5 11 over 7 1 7 and 3 10 over 7 times 3 1s 3 4 5 5 thirds. This up here, even though we did it by using common denominators this way, let's quickly say 13 over 3 minus 11 over 6. Draw the line and find the LCM. It is 6. 3 into 6 goes 2. 2 13s 26 minus 6 into 6 goes 1. 1 11 11. 26 minus 11 is 15. So it's 15 over 6. 15 over 6 all over 10 over 7 times 5 over 3. So 10 5 50. So 10 5 50 over 7 3 is 21. Alright, so you have 15 over 6 over 50 over 21. So it's 15 over 6 times 21 over 50. You cancel down. 5 into 15 3, 5 into 50 10, 3 into 6 2, 3 into 21 7. So it's 3 by 7 over 2 by 10. 3 7s 21 up top, 2 10s 20 down the bottom, and you end up with 1 and 1/20th. Alright, I'll see you in the next video.